For step 4, we calculate the between sum of squares. The between sum of squares is given by the following, where the groups are indexed using this lowercase j from 1 to k. So if k equals 3, you have 3 groups. You have j equals 1, j equals 2, j equals 3. For this equation, what's going on is that we take each group mean and we see how far off it is from the grand or overall mean. Then we square that value, so it's positive, and then we multiply by the sample size of that particular group J. The reason we multiply by the sample size for that particular group is so that we take into account the fact that different groups have different number of observations in many instances. So for our purposes here, we have n of 4 for each of those groups. Each group has 4 observations. There are 4 individuals in each group. Group 1 is 4 people, Group 2 is 4 people, and Group 3 has 4 people. That sort of weights this difference between each group mean and the overall mean. So when we calculate the between sum of squares, we just take these 3 group means, see how different they are from the overall mean, square it so it's positive, and then weight by the number of observations for each of those particular groups to take into account the fact that our sample size really consists of all these 12 different observations. So what we do is we take the mean of group 1, 2.5, subtract out the overall mean of 6.5, square it, and multiply by 4, the sample size for group 1. For group 2, we take the mean for group 2, which is 6.5, subtract out the overall mean across all groups and within groups, and we get that difference. We square it, and we multiply by that sample size for group 2. Then we take the mean only for group 3, subtract out that overall mean, square it so it's positive, and multiply by the sample size for group 3. When you do this calculation, you get this value of 128. That's a measure for the total variability between or across groups. We call it the sum of squares between, or the between sum of squares. We can visualize the between sum of squares by using 3 dots representing 3 group means. And then the dotted line is the overall or grand mean. What we're really doing here is we're saying how far off are each of these group means from the overall mean or grand mean. At this point, we've done all the sort of partitioning, all the separating of the variability in our data to calculate one-way analysis of variance. The important point here is that the overall measure of variability in our data set is the total sum of squares. It's just the squared distance from the overall or grand mean. It's the squared distance for each of our observations from the overall or grand mean. The within sum of squares is just the squared distance from the group or conditional mean. And then the between group sum of squares is the squared distance of the group means from the overall mean multiplied by the number of observations or subjects in each group. And this is sometimes called a balanced design. So let's double check that our calculations are correct that we've done so far. How can we double check? Well, the total sum of squares is the total variability in our data set. As a result, the total sum of squares, it will always equal the between sum of squares plus the within sum of squares. This is the nature of one-way analysis of variance. This should be true. So when you do a calculation by hand, or if you look at computer output, you should always check, is the total sum of squares equal to the between plus the within sum of squares? You should also think about what this means intuitively. All it's saying is that you have this measure of total variation. Right? It should equal the variation within each group, and it should also equal the variation across groups. To put another way, you can think of the variation within each group as all the individual level differences. How different is person A from person B? But then the variation across groups is really the differences between or across groups, saying how different is group A from group B. When you add that all up, you get the total amount of variability. So we say the total sum of squares will equal the within sum of squares plus the between sum of squares. So in our case, The total sum of squares is 143, the within sum of squares is 15, and the between sum of squares is 128. That's true. 15 plus 128 equals 143. Visually, it looks like this. The total sum of squares, all the squared distances for all these observations from the grand mean, will equal the squared distances for each of those group means plus the squared distances of each group mean from the overall mean weighted by the sample size for each group.